Hello class. Yesterday we covered simple interest. Today we are going to talk about compound interest. Let's look at my table note. I describe principal as chicken. Principal is the money you invest or borrow the very beginning. Or you can also treat principal as the amount of money on which the interest is generated. And I describe interest as X. So how does compound interest work? Let's say the very beginning you have one chicken. You invest in one chicken. Then during the first year, the chicken lay 4 eggs. So by the end of year 1, you have your chicken as the principal. You also have the 4 eggs as the interest from the first year. The special thing about the compound interest is your eggs are not going to stay as eggs. Instead, your eggs are going to turn into chickens and join in the principal group. So by the end of the first year, you have 4 chickens, but you have 4 eggs, but those eggs quickly become chickens. So the beginning of year 2, you will have 5 chickens. So beginning of the second year, your principal is not the original 1 chicken anymore. Your principal is the sum of your original 1 chicken and your interest. So you have 5 chickens the beginning of year 2. During the year 2, since every chicken has the productivity to lay 4 eggs, and you have 5 chickens, so during the second year, you would harvest how many eggs? 20 eggs, right? 20 eggs. And those 20 eggs will quickly turn into chickens as well. So the beginning of year 3, your principal grows again. Not 1 chicken the very beginning. Also not the 5 chickens. Instead, it grows to 25 chickens. That is the original principal and all the accumulated interests. So during the third year, your interest rate is going to apply on the new principal, the 25 chickens. So during the third year, every chicken gives you 4 eggs. The 25 chickens will give you 100 eggs. So as you can see, since your chickens becomes eggs, make your principal grow. You would have more chicken, and more chicken lay more eggs become more chicken, and you would have a lot of asset, right? So very powerful. When people say exponential growth, you can refer to this example. Very powerful, exponential growth. And the difference between simple interest and compound interest is, in the case of simple interest on the left side, your original principal will remain the same over years. And every year, your interest is a fixed amount of money. But in the case of compound interest, your principal every year is different. Your principal grows every year because the interest from previous year will become part of the principal, and the interest rate will be applied on the growth principal. That's the main difference. So just refer to this table. In the case of simple interest, chicken remains as chicken, eggs remains as eggs. But in the case of compound interest, chicken, lay eggs, but those eggs quickly become chicken. So you have more chicken, and more chicken lay more eggs, and those more eggs become chicken. So your principal is growing. So you have more and more stuff, right? So that is my table now. The point of this table now is to compare and contrast the difference. Compare and contrast those two important interests, simple and compound. And now we are going to, and we have Ashley, Lauren, Leon, Natalia. Okay, very good. So now we are going to start the section 8.4 compound interest. Yeah, let's practice some questions in this section. Oh, I need to log in again. Let me do it again. So sorry about that. It's been hours inactive. And by the way, this week you're supposed to take your test 1.
Are we supposed to be hearing sound? I'm sorry, I don't hear anything.
Oh, I wasn't talking for just a minute. Can you hear me right now? Let me see. I think I unmute myself. Natalia, are you able to hear me right now? I think yesterday you have the same issue. Let me type. Natalia. Oops. Oh, okay. What is this? Can you hear me now? I think you had the same issue yesterday. You would have to fix it. I don't think it's my problem. Okay. Let's continue. We're going to start practice 8.4. Compound interest. Round the decimal to the given place value. We need to round this decimal to the nearest thousandth. Okay, thousandths. 2 here is tenth. 0 here is the hundredth. 1 here is the thousandth. So when you look at the digit next to it, which is a 6, so following the normal rounding rule, we should round it up, and the decimal would be 45.202. 1 rounded up to 2. It's a simple rounding problem. And this is a division. And I think I would leave those problems to you to practice. And this is to express percent to decimal. Just drop the percent sign and move the decimal point 2 places to the left. And those is from decimal to percent. Yeah, I'll leave those for you to practice. We had exactly the same problem yesterday. Number 6. Okay, let's look at this. Fill in the blank such that the resulting statement is true. In the formula, P equals A over 1 plus R over N. In the parentheses, if you watched my video, you probably have not yet. You know, whatever inside the parentheses, we call that compounding factor. We raise the compounding factor to the power of n times t. So this formula, the variable what represents the amount that needs to be invested now in order to have how many dollars accumulated in how many years in an account that pays the rate equal to compounded how many times per year. So this is how do we understand the variables in the formula. P here is called the principal, okay? Original principal. P here is the original principal. As I explained earlier, in the case of compound interest, the principal is growing. So P here is the money originally you invest to have $8. A is the initial of accumulated balance. So A here represents the accumulated balance. In T years, T here represents time in year, is the time that you keep your money in the savings account. Interest rate, R, is the annual interest rate, okay? Annual interest rate, compounded n times a year. In my table note, when I explain the chicken eggs compound interest, the chicken lay eggs once a year. If the chicken lay eggs once a year, we say the interest is compounded once a year or annually. What if the chicken lay eggs twice a year? The first time, if you invest the chicken at the beginning of the year, the first time is the end of June, the second time is the end of December. Then we say the interest is compounded semi-annually. If the chicken lay eggs 4 times a year, every 3 months, then we say the interest is compounded quarterly. If the chicken lay eggs every month, the end of every month, then we say the interest is compounded monthly. What if the chicken lay eggs every day, the end of every day, then we say the interest is compounded daily. And there's another case, if the chicken lay eggs continuously, then we say the interest is compounded continuously. We have the formulas in the guided note. Give me 1 second. And I think I have another table note. Yeah, here. I have another table note to demonstrate the process and with the corresponding formulas. Yeah, this is a good table. When we talk about compound interest, we have more formulas, a lot more formulas than simple interest. We have the formula for the interest compounded annually. We have the formula for interest compounded semi-annually, quarterly, monthly, daily, or even n times a year, and or continuously. So you need to understand those formulas. You need to watch my video first, then you understand it. And n times a year. N here is the number of times the interest is compounded every year. When n equals 1, annually. N equals 2, semi-annually. N equals 4, quarterly. N equals 12, monthly. N equals 365 or 360, daily. N approaches infinity, that is continuously. Multiple choice question. Determine whether the following statement is true or false. If the statement is false, make the necessary change to produce a true statement. Formulas for compound interest show that $1 invested today is worth more than $1 invested in the future. What do you think? The dollar today is worth more than $1 in the future. That's true. 2. 1 + 1 = 2. 2 + 1 = 4. 4 + 1 = 6. 6 + 1 = 12. 12 + 1 = 24. 24 + 1 = 26. 26 + 1 = 28. 28 + 1 = 30. 30 + 1 = 40. 40 + 1 = 50. 50 + 1 = 60. 60 + 1 = 70. 70 + 1 = 80. 80 + 1 = 120. 80 + 1 = 150. 80 + 1 = 160. 80 + 1 = 170. 80 + 1 = 180. 80 + 1 = 190. 80 + 1 = 191. 191 + 1 = 240. 240 + 1 = 260. 240 + 1 = 270. 270 + 1 = 280. 280 + 1 = 290. 290 + 1 = 260. 260 + money has time value, not just interest, also inflation. Question number 8. The principal represents an amount of money deposited in a savings account, subject to compound interest at the given rate. Let's look at the table on the top right corner. Principal is given $9,000, annual interest rate 4%, compounded semi-annually. Time is 3 years. So those are the information about this compound interest savings account. We need to answer the following two parts. First part, the amount of money in the account after 3 years is the amount of money in the account in the future. That is A, okay? That is A. So let me get my table note. I'm going to use 2 different methods. Same with my video. My class video for this section, I use 2 different methods. So firstly, you need to know this formula, okay? Compound interest formula. A equals P times 1 plus R over N to the power of NT. And A is the accumulated balance or future value of your account. Principal is your original money, the original money you invested. R is the annual interest rate. T is the time in year. N depends on how does the interest is compounded. In our case, N equals 2 because the interest is compounded semi-annually. You see that? Semi-annually. So your interest is compounded twice a year. So N equals 2. Very important. Okay? And your P equals, I need to look at the information. 9,000, 4%, 3 years. 9,000, 4%, 3 years. 9,000, 4%, 3 years. Okay, then now we are going to plug in all the information we have, okay, to the formula. Yeah, this formula you need to remember. So A equals P, 9,000, and 1 plus annual interest rate, 0.04, divided by 2. Then this rate is called the semi-annual interest rate. And 1 plus semi-annual interest rate is the compounding factor in this case. New exponent n times t equals 3. So interest is compounded twice a year over 3 years. So the total number of times your interest is compounded is 6 times. All right. So in my video, I explained this formula actually is very easy to remember. Okay, from P to A. From P to A, compound interest. Every time your interest is compounded 1 time, you just need to multiply by the compounding factor. Every time your interest is compounded, you just multiply by this factor 1 time. Yeah, depends on how many times the interest is compounded. If n times a year for t years, then in total n times t times. That's how do we have this exponentiation. Yeah, please take time to watch my video. And now let's calculate. All right, so 0.04 divided by 2 is 0.02, and then to the power of 6. And then 9,000 times 1 plus 0.02 is 1.02 to the power of 6. And let me share my calculator. So from this section, I'm going to frequently use the TI-84 calculator. Okay, frequently use the TI-84 calculator. Okay, are you able to see it?
Yes.
Okay, awesome. Let's see. Okay, so I turn on my calculator. I'm going to go back to the calculation mode and I clear my calculator. Yeah, so I remember it's 9,000, right? 9,000 multiplied by, I put a parenthesis to frame the base. It is 1.02 and close the base and raise the base to the power of 6. And I got this number. So in 3 years, the value of your savings account, in other words, your accumulated balance in your savings account is going to be $10,135.46. Yeah, depends on how we round it. Okay, yeah, please write down this number. Please write down this number because we are going to use a different method to get this problem done. And I hope you grasp the second method. Grasping the second method will make your job this chapter super easy. Okay, second method is to use TVM solver in this TI-84 calculator. Okay, so how do we find the app? You will find this key, APPS, and click the APPS apps. The first app is finance. I used to have another calculator has more than just that app, but this calculator only has this app. But that's enough for our course. And confirm finance. And the first function in this menu is TVM solver, right? Yeah, we are going to select TVM solver. What is TVM? T is time, V is value, M is money. TVM means time value of money solver. So we are going to use that function. And you will see this menu. You will see this menu. So let's see how do we put in entry. Yeah, enter the entry to get the answer that we are looking for. The capital N here is the total time that your interest is compounded over the 3 years. Remember, it's semi-annually, right? Twice a year for 3 years. So 6 times, right? 6 times. So that's the first entry. Second entry, I%, that is the annual interest rate. What is our annual interest rate? Let me see. 4%? Yeah, 4%. You know what? You don't even have to convert 4% to equivalent decimal or whatever, because the percent sign is already there. All you need to do is just enter 4. It's easy, right? Annual interest rate is 4%. Then you just enter 4 there. Just enter 4 there. And then go down. PV. PV is the original principal, right? Originally, you investing how much money? 9,000? Let me have to double check. Yeah, 9,000. So PV, present value. PV represents present value is 9,000. 1, 2, 3. Yeah, that's how much money you deposit in the account at the very beginning. So we're at right now at this time. So it is called a present value as well. And then you will see PMT. PMT represents the payment. Since during the 3 years, you do not withdraw, you do not deposit more money. So just leave payment as 0. Okay? Yeah. In the later sections of this chapter, we are going to use the PMT a lot. But when we use this app for the purpose of compound interest, always put a PMT payment as 0 because we do not invest, we do not deposit or withdraw during the 3 years. We only do the one-time investment at the very beginning. That is present value, $9,000. And future value is what we are going to solve for. Yeah, you can put any number. I always put a 0 to hold a place. Otherwise, it will not let you to continue. Yeah, put a 0 to hold a place. We are going to go back very shortly. And now, very, very important. Do you see P per Y and C per Y? P per Y is the number of compounding periods every year. So since it's semi-annually, and so it's a payments every year. So don't worry about that. C provides a compounding number of compounding period every year. Since it's semi-annually, is 2, okay? Is 2, twice a year. And you need to know is P per Y and C per Y. Those two values must be equal. If you change the first one as 2, automatically the second one, the C per Y, is also changed to 2. And the last item on the bottom, always leave the end highlighted. The whole chapter, our course, only use that type of investment. Okay, so I said that we are going to go back future value because future value represents the accumulated balance of the account in 3 years, right? You see the indicator is blinking right now, right? At a pay, sorry, it's not payment, it's future value, yeah. So it's blinking at the future value, right? And then you are going to push alpha enter. Alpha is this green key, alpha, and then enter. And then you will have the future value or the accumulated balance of your savings account in 3 years. Is that the same value? Huh? $10,135.46. Same value or different value? Same value. Do you see that? Yeah? Okay, question. Question? Do you like the second method? Use the app. All good here. Thank you, Lauren. What about Ashley, Layan, and Natalia? Thank you, Layan.
Yes, ma'am. I'm good.
Thank you, Natalia. So actually, I assume you're fine. If not, email me. And also just watch my video. I have everything explained very clearly. Okay, so that is our answer. Now I'm going to go back to share the whole screen. Right, so yeah. We're going to answer this. We're going to round it to the nearest hundredth. So that is the nearest cent. After 3 years, we have $10,135.46. 46 cents. It worked, right? Yeah, very important. I hope you spend time to learn the second method because it's so convenient. If you grasp the method, you will not be afraid of test 2. By the way, test 2 in history has average low score. But if you really pay attention and make effort to learn the second method, make your job easier, you can get a very high score. I said that for your own case, for your own sake. Part B, what's the amount of interest earned? Okay, so how do I get that done? How do I understand that? So in the beginning, you invest. In the beginning, you invest $9,000, right? And in 3 years, you have more than 10 grand. Isn't the difference between the original money and the principal is the interest? So we are going to use 10135.46 to minus 9,000. 1, 2, 3. And the difference is the interest. 1135 0.46. Is understandable? It's pretty straightforward, right? In the beginning, you only invest $9,000, and after 3 years, you got more. You got more, 10 grand, more than 10 grand. Of course, the difference is your gain. Yeah, if you are earning, is your interest. Okay. Question number 9. I think this is the same, right? Yeah, same. Okay, the principal. Yeah. Part A. Find how much money there will be in the account after the given number of years. Okay, I'm going to sort the information here. And I want you please do the same thing. What thing? Copy down the information on your scratch paper. Yeah, just grab a paper and write it down. We have a principal, P equals 7,000. We have an annual interest rate 3.5%. And we have N equals 12 because the interest is compounded monthly. And we have T equals 2. And same with earlier, we are going to use 2 different methods to solve this problem, okay? Yeah, the first method, let me give you the formula again. I hope you remember this formula because it's a very important formula. And P is 7,000. R is 3.5%, 0.035 over 12. And then to the power of 12 times. How many years? 2 years. 12 times 2. The interest is compounded 12 times a year for 2 years. So the total number of times your interest is compounded is 24 times. All right. So I'm going to show you. Yeah, please have this in your scratch paper, because once I switch to the calculator, you will not see it. Yeah, I'm going to share my calculator. Okay, turn it on. And so this is clear. Yeah, I am able to use this calculator, TI-84 calculator, to enter the expression that I have just written on the note, on the OneNote. So 7,000 principal multiplied by a parentheses. And in the parentheses, we have a 1 plus the monthly interest rate. Monthly interest rate is the annual interest rate, 0.035 divided by 12. So now I close the monthly interest rate and then close the compounding factor. And then I'm going to raise the compounding factor to the power of 24. And then enter. And I would have the future value of the account. So the beginning you invest in $7,000. So in 2 years you will have $7,506. So 2 years you have over 500 gain. Yeah, annual, like every year you have like over 250. That's pretty good. So that's the first method. Of course, if you want to manually calculate, manually evaluate the expression, no problem. It's really your option. It's really your choice. I'm just trying to give you the better option. I think it's worth it to invest in this type of calculator. By the way, I'm not selling this, and I have nothing to do with the company either. It's just very convenient. If you can go to our campus, any campus, the Math Tutoring Lab provides TI-84 calculator, but you can only borrow the calculator for 1 day. Yeah, let's say you have 1 day off from work and you go to the campus in the morning, and you can borrow the calculator, and then you can use for the whole day and do the homeworks that you could use the calculator to solve. Also, when you go to the testing center, you can also check out the calculator, right? Just for that day. That's one option. So now let's use the second method, the app. Go to apps, finance, TVM solver. Okay, we see this manual again, right? The compound interest is compounded 12 times a year, monthly, 12 times a year for 2 years. So 12 times 2. You don't even have to calculate. The calculator will do that for you. And the interest rate, what is the interest rate? 3.5, right? Test question, are we allowed to take, wait 1 second. Are we allowed to take a note card with the formulas listed, or do the formulas need to be memorized? The formula need to be memorized. The tests, all the tests, yeah, all the tests are gonna be closed book, closed note. Okay, thank you, Lauren, for the question. And let's continue the the manual. Yeah. So what is the annual interest rate? 3.5%, right? Let me see. Yeah, 3.5%. So you only need to enter 3.5. Very convenient. And then present value, you invested in $7,000. So $7,000. The payment is 0 because you do not deposit more during the 2 years or withdraw anything. And future value is what are we going to solve for? We can put a 0 for now. And anyone can tell me, how do we entry for this item? P per Y and C per Y. By the way, the interest is compounded monthly. Should we keep the 2 or change the 2 to another number? Huh? Should we keep the 2 or change the 2 to another number? The interest is compounded monthly, 12 times a year. Yeah, I'm waiting for you to respond me. We had a 2 from the previous question because the interest is compounded semi-annually. But this question we are working on, the interest is compounded monthly. So what number should we have there? Perfect. Thank you, Liam. 12, exactly. So we enter 12. As you can see, once I go down to C per Y, automatically C per Y will change the same value, right? Yeah, so you don't have to enter 12 again. Now we go back, future value. You can see it's blinking at the future value. And then alpha, enter. So in the future, in 2 years, the accumulated balance of the account would be $7,506. Yeah, $7,506.79. Same with earlier. I can go back to show you. Same with this answer. Exactly the same, right? Okay, so let me share the note. Let me share the assignment. Let's go back. Round to the nearest hundreds. That means the nearest cents. We have $7,506. How many cents? Rounded down, 79 cents. 79 cents. Right? Next, we need to find a problem that funding the, okay, we need to finish part B. Find the interest earned. the interest would be the difference between the accumulated balance and the original principal, right? Minus 7,000. So that's easy. Just the $506.79. Okay. We need to find a problem that is looking for principal. What is the, okay, this is also accumulated. Let's go down. Let's see if it's 11 is to find a, okay, this one. Let's look at this. Good news is some problems will give you the formula, but they will not give you exactly the formula that you need to apply. They will give you multiple, and you need to know which one to choose. So it's good that you remember, you really understand the formula. Yeah, I only make you to memorize the formula that you can remember once you understand. I will not make you to remember formulas that is very complicated. It takes time to prove. I will not do that. But the compound interest formula, you should remember it. And it is not difficult to remember once you understand. From P to A, every time the interest is compounded one time, just multiply P by the compounding factor one time. And let's see this problem. How much money should be deposited today in an account that earns 5% compounded semi-annually, such that it will accumulate to 8,000 in 3 years? Let me write down the information here. Okay, let's write this formula. P equals A over 1 plus R over N to the power of NT. So this time we go from A to P. What is go from A to B? P. A is our financial goal in the future. In order to achieve that financial goal, how much money we need to invest today? So from A to P, we are doing discounting. Okay, from P to A is compounding. From A to P, the process is called discounting. So instead of calling the same thing compounding factor, we call this factor discounting factor, but it's actually the same thing value-wise. And then this is the how many times your interest, your amount of money discounted. So in our problem, let's see what is our financial goal. Our financial goal is 8,000, 3 years. I need to remember this. 8,000, 3 years. What's the annual interest rate? 5%. So 8,000, 3, 5%. 8,000, 3, 5%. Yeah. How does the interest compounded? That's a very important information. Compounded semi-annually. Okay. Semi-annually. That means what? Means n equals 2, right? Okay. So we're going to plug in all the values that we have. Numerator 8,000. Denominator, the compounding factor or discounting factor, 1 plus 5%, 0.05 over 2. So 0.05 over 2 is the semi-annual interest rate. And then to the power of 6, twice a year for 3 years. So the total number of interest compounded is 6 times. All right, so you can enter this to your calculator. Would you mind to show me how many of you have the calculator with you now? It probably not much. So we can simplify the base of the denominator. That is 0.025, so 1.025 to the power of 6. Yeah. Let's use the calculator to find the value. Please write this down on your scratch paper, since you will not see it once I share my camera. I wish I had the emulator, TI-84 calculator emulator installed on my personal device, but it is not allowed to on my personal device. Share camera. Yes. Okay. So turn it on and clean everything. Clear everything. So I have $8,000 as a numerator. Okay. 1, 2, 3. Divided by. I'm going to use a parenthesis to frame the whole denominator. The denominator is a power with base 1.025 and to the power of 6. And then close the denominator. The way you handle the expression in the calculator is a very good practice of understanding the structure of expression. The reason the first worksheet we practice is the order of operations is because you do need to have a good understanding about the structure of expression. So we got this number, okay? Let's remember that. $6,898.37. Can we use the app to get the same result faster? Yes, let me show you. Go to the apps, finance, TVM solver. Okay, let's see. For how many years? 3 years, right? Semi-annually, 3 years. So twice a year for 3 years. Oops, do that again. Twice a year for 3 years, so 6, right? In total, your interest is compounded 6 times. And annual interest rate 5%, so 5 here. Present value, that's the value we are going to look for. So we don't know. Yeah, that item, PV, present value, is the thing we are going to solve for. So you can put anything there, and we are going to go back shortly to solve for the item. Payment remains 0. What's your future value? You want to have $8,000 in 3 years, right? So the future value is 8,000. Since the interest is compounded semi-annually, we do not have 12 there. We need to change that to 2. Okay? Automatically, the C per Y also changes to 2. And then now we go back where? Go back present value, PV. Yeah, how much money we need to deposit today in order to guarantee in 3 years we can have $8,000. So you see it's blinking to the right of PV present value. Let's solve for that. Do we have the same value? 6098. Let me double check. 689. Yeah, exactly the same, right? It's the same value. So the app is it's kind of like a shortcut. Let's go back. Our assignment. So amount of money we need to deposit today, round it up to the nearest cent. Okay, I need to stress this part. Round it up. You need to read the instruction. Why do we need to round it up? If you look at the decimal we got is 6,898 $37 and 4928. Yeah, I'm not going to sum it. I'm just enter the decimal I got from the calculator. So if we following the normal rounding rule, we're supposed to round it down because the 4 here is less than 5, right? However, the instruction here says round it up. when you see round up, you always have to get rid of, forget about the normal rounding rule. It doesn't matter if this digit in the thousandth place bigger than 5 or less than 5, doesn't matter. You always have to round it up. Change the 7 to 8. Okay? Why? Because otherwise you might be a little bit short to reach your financial goal, $8,000 in 3 years. So when we deposit the money, we want to 100% guarantee the financial goal will be reached, right? So we have to always round it up. This is the first time we see this kind of problem. In future sections, we have a similar problem. Yeah, when you deposit, when you invest to guarantee a future financial goal, when you round the amount of money you need to invest, you always need to round it up. Okay, so you don't have to. The easy way to do that is read the instruction. You don't have to remember exactly. Just read the instruction. When you see round up to the nearest cent, then you just round it up, because it doesn't say rounded to, right? If it's rounded to, then that is a fault. That is a normal rounding rule. If it's rounded up, that means you always have to round it up. Doesn't matter if the next digit is bigger than 5 or less than 5 or equal to 5, doesn't matter. You always have to round it up. Let's check this answer. Is correct, right? Yeah. So this section, we have two types of problem. Either you have the original principal and you are looking for the future value or accumulated balance of the savings account. Pays.
I'm going to take a picture of this 1 second, please.
Which one? The right now? The note? My one
Yes,
note?
ma'am, I got it. Thank you.
Okay, no problem. Yeah. And then the other type of problem is we know our financial goal. We have a savings account over there that could help us to reach the financial goal. And we need to determine how much money we need to deposit today in order to guarantee the financial goal in the future. All right. So we covered both type of problems. Important thing, when we look for the present value, we need to always round it up. Okay, guys, so that's for today. Please watch my video. I'm trying to advertise my video, but when I look at this, the usage, it doesn't have many views. I don't know, maybe you are busy, but what I can do is I just keep advertising. If you have any questions, feel free to email me. I'll see you tomorrow. Have a good evening. See you guys. Thank you, Lauren.